Hi everyone. Now I am going to discuss about the type of forces and how to draw the free body diagram. Various type of forces are there. That forces I am going to discuss now. First, I will explain what is a free body diagram. We can write this in short form as a FBD. Free body diagram is nothing but it is a diagrammatic representation of forces acting on the body. Forces acting on the body. This is a meaning of a free body diagram. Now you observe this carefully. We have to take only forces acting on the body, not by the body. Forces acting on the body. Now, before drawing this free body diagram, I will explain the type of forces. First one, non-contact force. Non-contact force. These non-contact forces we can see like a weight of the body, gravitational force, electrostatic force. These all forces will come under this: weight, electric force, electrostatic force, etc. These are the non-contact forces, or you can say force at a distance. First, I will give the what is the meaning of weight. We don't want this electrostatic force. We are going to discuss in this chapter weight only. Weight is nothing but it is a gravitational pull. Gravitational pull. How this gravitational pull will be there? Let us consider there is a earth. And this is center of the earth. If any object is kept, have mass m is kept here, the weight of the body will be always acting towards the center of the earth. If I place any body of mass m here, it is always act towards the center of the earth. If I place any object of mass m here, it will be acting towards the center of the earth. Everywhere, if I place the mass of the object here, the weight, whatever weight is there, that is mg will act downward direction. Okay. Now I can write it as weight W bar can be written as m into g bar you can write. This is a weight acting on your body. What is its direction? Its direction is always towards the center of the earth. Center of the earth. Now, but actually according to us, center of the earth means we cannot see that, but we can see earth is almost all horizontal surface only. If it is a horizontal surface according to us, now you can take that if any body of mass m is placed somewhere, weight of the body is acting vertically downward direction. Vertically downward. This is the weight of the body. The free body diagram of this is mg. That's all. The force acting on the body is mg. That is only free body diagram of this weight of the body. Okay. How this weight will be there for different cases. We can see how this free body diagram of this mg. Let us consider that there is a body of mass m is placed here. Now we can see that weight of the body will act as a mg downward direction. Now, if I take the any body like on inclined plane, if I take any inclined plane and a body of mass m is placed on inclined plane, we can see my weight of the body will be acting downward direction. Okay. If I resolve this weight into two components like a x-axis as well as y-axis, now you can resolve this weight into two components. Now we can see weight components are like this. This will be theta. Now we can write the value is mg cos theta one direction and mg sin theta will be another direction. These are the actually resolution of vectors. Okay. Now weight only force acting is mg only, like this mg value will be acting. Okay. Next force we are going to see that is contact forces. What are the contact forces? We are having the contact forces are tension force, contact forces, actually these contact forces are actually electromagnetic in nature, means between molecules it will be exist. Okay. Okay, in nature it will be electromagnetic in nature. There are some kind of forces are there here. I will write one by one. First one is normal force, or normal reaction. We can represent this as a normal reaction. If I take any body of mass m which is placed on a surface, horizontal surface. Now for this body you can see how this contact is there. You can see contact is there everywhere. Throughout the body contact is there with the surface. You have to take any center of this contact point is we can see, and n is acting upward direction, which is acting 90 degrees to the surface of the contact. We can see that a force which acts perpendicular to the surface of the contact is normal force. Okay, this is about the normal force. Normal reaction or normal force is it is a pushing force. Okay, normal force is a pushing force. Observe this carefully, it is a pushing force. Okay, now always it acts perpendicular to the surface of the contact and away from the surface. Normal force always acts away from the surface. N always acts away from surface towards body. Okay, how it is acting, we can see in this case it is away from that. I am going to write the different normal forces, how this normal reaction free body diagram is there. If I take the vertical wall, body of mass m is placed here, and I have applied here pressing force. I have pressed this body of mass m against the wall. You can see this wall is having contact with the body. Now you can see which is the center point is on this center point normal reaction will be there. Okay, now you can see if I take the any body of mass m here, the pressing force is like this. Normal reaction will be opposite direction. Okay, by the wall we can see at 90 degrees the normal force is acting. If I take the another example like this, if any body of mass m is placed here, we can see the contact points are, we can see contact is like this. Now we have to draw a line which is perpendicular to the surface of the contact. This is perpendicular to surface of the contact, normal reaction will be like that. Okay, if you want to resolve the normal reaction into x-axis and y-axis, suppose if you want to resolve like this, theta is there, we can make the lines like this. Okay, this angle will be theta and this angle also theta. We can write n cos theta and n sin theta terms we can resolve. The main force is normal reaction will be like that. Similarly, if I take the body, a V-shaped groove is there, and if any a body is kept like this, any body of mass m is kept here like this. Whenever any body is kept here, we can see that how it is there. We can see now on this body, you can see how many contacts are there. Here one contact is there, here one contact is there. Always whatever normal contact is there, it will be acting towards the center of the spherical body. So we can write the n1 contact, here contact 1, here contact 2. So contact 2, you can see normal reaction is like this. This is a normal reaction contact at the contact point 2. Similarly, if I draw the any other diagram like this, two balls are kept in any a box type is there, just it is placed like this. You can see how this body is kept here. You can one more body is kept here like this. Like this, one more body is kept. Okay, whenever this body is kept, you can see how these contact forces are there. Now contact, here one contact is there, here second contact is there, and here third contact is there, and here fourth contact is. Now you can see the center of this body is like this. So you can say normal contact is 3. Here center is acting, so towards the center it will act n4. And you can see on one body this value is n2 is like this. On other body n2 will be downward direction. Similarly, n1 is there, no, that n1 will be towards the center of the another sphere. Okay, like this contact forces will act always perpendicular to the surface of the contact. Wherever surface is there, we have to write a line here also at point 2, perpendicular to surface of the contact, normal reaction will act. Same manner, if I take the any rod is located like this, I am taking a rod is kept like this on the floor. Suppose if you want to write the normal forces directions, normal force direction, if you write that one contact is here, so I can write the one contact and second contact is on horizontal surface. Now you can see perpendicular to this surface is n2 is there, and perpendicular to the first surface is n1 is there. Now if I take the one more diagram, same, if I take any rod is located like this. So total length of the rod is there, no? That length of the rod is outside the surface is located. Now one contact is here, second contact is located there. We can see the normal reaction at the horizontal surface is n1, which is perpendicular to that. And the second one diagram, you can write that perpendicular to the surface of the contact, we have to write this is a perpendicular to surface of the contact. n2 is acting like this. Okay, you can observe that how these normal forces are acting on different contact points. Okay, this is about the normal forces and how these normal forces diagrams are there, we can check. Okay, next one, tension force. And one more force is there. Before writing that, friction, more detailedly friction I will explain later. Friction is nothing but the, I will write again, friction, the force which opposes relative motion between two surfaces. Relative motion between two surfaces. Which are in contact each other. Okay, let us consider that there is a block of mass m. I am taking a block of mass m. This block m is kept here on the surface. It is a rough surface. If the body is moving like this, in that case, due to this roughness, we can see that these points are there. No, they are actually a contact here, and frictional force is opposing the relative motion between the surfaces which are in contact. Okay, now we can see friction is acting. Frictional force always acts opposite to relative velocity direction. Relative velocity direction. We can write that F bar is equal to negative of V relative bar. Okay, or we can write it as F cap, whatever the unit vector along friction, you can write F cap is equal to negative of V relative cap, you can write. Okay, unit vector. Now overall we can see that friction is always parallel to surface of contact. Okay, friction always like this. Okay, it will not oppose the motion of body. It opposes the friction will not oppose the motion of the body. Sometimes it support, sometimes it opposes. But always it opposes the relative motion. Relative motion. Okay, now we can see actually why I am telling is, suppose a person is walking on the any road. Here he is able to walk on the surface or ground because of the friction only. Whenever he is pressing that, here friction is supporting him. Friction actually supporting the person. Friction support to walk. Support to walk on rough surface. Understand that? If it is oily surface is there, you will slip. Understand that? Now you can see friction will not oppose the motion of the body or motion of the any body, moving body on the surface. Okay. Now this is about the friction. More details about the friction we will discuss in the later case also. But I am drawing the free body diagram, the friction, how the free body diagram will be there. One of the case I am giving like a mass m is located, a body is moving. In that case, frictional force will be acting like this. Okay, suppose say a body is like this, placed against this. If someone is pressing this and body is about to move downward, moving like this, in that case friction is acting upward direction. Okay, suppose say a block is kept here and one more block is kept. Now if I apply the force on this body, now on upper block friction will be acting forward direction. Friction will be acting upward direction, forward direction. You can, if you want, you can see on upper block F is upward direction, on lower block F is actually left side will be there. This is the actually picture for the friction. Okay, I am telling you that for the upper block friction is acting forward direction, on lower block friction is a backward direction is there. Okay, it indicates that friction is supporting the motion of the upper block. Okay. Similarly, it is opposing the motion of the lower block, as there is a relative motion between the two surfaces. Okay. Next force is tension. Tension T. Tension is nothing but the forces developed in the strings or threads. Forces developed in string or thread when objects connected to string or thread. Okay. Now actually you can see one of the relation here. I am taking a string. If I connect any body of mass m, okay, now you can see wherever contact is there, here contact is there to the body, tension will be upward direction. Okay, here contact will be there, tension will be downward direction. As I have taken a massless string, throughout the massless string, tension will be same. Okay. Now you can see tension is acting along the string. We can see now that we can say tension is a pulling force. It always acts parallel to string and towards string. Towards string it will act. Observe this carefully. This is the tension in the string. I will give the different relations for the string forces, how it is there. Now I am taking two bodies now. Let us consider body 1 and here body 2. There are two strings, string 1 and string 2. If you want to draw the free body diagram, here contact is there, wherever contact is there you can write T1. Here contact is there, you will write the T2. So T2 on bottom second body upward direction is there, on first body downward direction will be there. Wherever contact is there, we have to write the tension. Now we are seeing only on the bodies now, first body T1 upward, T2 is downward for the lower block. Similarly, if I take the any string is connected to the block like this, now you can see tension developed in this string is like this will be there. Whenever I apply any force, you can see tension will be developed like this. Okay, observe carefully how to draw the free body diagram for the tension. Okay, tension force will be acting like that. More detail if you want to get the some other relations, let us consider that there is a string is I am taking like this. If I connect the bodies are like this, we can see I have taken one body, okay, and a point is connected here. So I can see how many tensions are there. This is a string 1, so tension 1. On the body, tension 1. Now here string 2 is a tension T2. Here string T3 is a tension T3. Like this tension force will act on the any string. Okay, it will be like a equal and opposite direction. Why equal and opposite direction I am taking here? Whenever string is there here, we can see at wherever contact points are there. Suppose say if I connect a body here and here also one body is connected, on this body tension will be like this, other body I will write like a little detailedly. Suppose if I write like this, here contact is there T, here also T. Similarly here T and here also contact is there T, you can write. This is the our tension forces. Okay, tension forces how it is acting on each and every body, you can check that on body as well as on string. Okay, if string is massless, then tension is same throughout the string. Tension will be same throughout the string. Next, if string is massive string is there, tension will be different at different points, different at different places, different points, different points. So you can see that how this tension force will be there, we can observe. This is about the tension force. More detailedly you can I will discuss. Okay, like problems, connected bodies and all, there is there I will explain tension forces. Next force is spring force. Let us consider there is a spring having spring constant is K. It is a material property. Now I have connected this to a block of mass M, and I am pulling this body with like this. I am pulling. Whenever I am pulling, you can see that because of this pulling, the block is actually moving right side, and the string is getting elongated. Now you can see string is elongated from one point to another point. This is displaced by x. Whenever string is elongated, so it is elongation in spring. Elongation in the spring. Now if I remove the force, immediately you can see that body will come back. Why it is coming back? Because spring is actually acting some force, exerting some force on the block. The force acting on the block will be left side. We can see the spring force is equal to minus k into x, we can write. What is the meaning of this minus k? Minus sign indicates spring force is opposite to x. That is the meaning of negative force. Okay, negative sign. Now suppose if I compress the spring, what will happen? If I compress the spring to this point, if I compress this, now you can see instead of initial point, you can see it is compressed. If I remove the force, immediately you can see body again try to come like this, right side. So whatever spring force is there, here also I can write it as minus kx. Spring force is a minus kx. K is spring constant. So I have written already, K is a spring constant. Observe carefully, this is about the spring force. Next one, you can see whenever a spring is given to you, let us consider spring constant K, length L. Now what I am doing is, this spring I am cutting into two equal parts. Like this I am cutting. Let us consider that this I am cutting with two equal parts. Cut into two equal parts. If I cut into two equal parts, now it becomes like a first spring is like this, and the second part will be like this. Now I am taking this is K1 and the length is L1 is equal to L by 2, and K2 and the length is L2 is equal to L divided by the 2. Whenever I am cutting, no, force will not change. Force is same. force will be same in spring. Immediately it will not change that. So we can say that K into L is equal to K1 into L1, that is K2 into L2 we can write. So K into L1 is equal to K1 into L by 2. From this we can write the K1 is equal to 2K. Similarly, K into L is equal to K2 into L by 2. We can get the K2 value is equal to 2K. So these are the new spring constant of the each part. Suppose say if I cut the spring into 3 equal parts. Cut the spring into 3 equal parts. Spring into 3 equal parts. If I cut the spring into 3 equal parts, we can get the springs like this. K1 L by 3. Next K2 L by 3. Similarly K3 L by 3. As per our relation, as F is constant, we can say that K into L is equal to K1 into L by 3. So we can write K1 is equal to, we can write it as 3K. If K1 is equal to 3K, K2 also 3K. We can see K3 also 3K. These are the spring constants. You can observe that carefully, the spring constant values. Okay. The same manner, if I cut the spring like this, K and length L is there. If I cut the spring as like a K1 and L1, and the second part is like a K2 and L2. If L1 is to L2 is equal to 2 is to 3, then we can write it as L1 is equal to 2L divided by the 5. L2 will be 3L divided by the 5. Now, as per our relation, KL is equal to K1 into L1, K into L is equal to K1 into 2L by 5. We can see that K1 value is equal to much? 5K divided by the 2. Similarly, KL is equal to K2 into L2. You can get the K into L is equal to K2 into 3L divided by the 5. Now we'll get the K2 value is equal to 5K divided by the 3. These are the spring constants of the new whatever the parts are there, no, that cutting parts. These are the K1 and K2. Observe this carefully, how to write these springs relations. Now here only I will explain about the springs are in series also, parallel. Springs are in series and parallel. If springs are connected in series, we can see that whenever the two springs are connected series like this, K1 and K2 is connected, one end is fixed, other end is connected to a block of mass M. Now in this case we can write it as force is same. Force will be same. If force will be same, then we can write it as X is equal to X1 plus X2. We can write 1 by K effective value can be written as 1 by K1 plus 1 by K2 we can write. This is a springs are connected series. Springs are parallel. Are in parallel. Whenever springs are in parallel, you can get that they will be having same elongation. Both the springs which are connected in parallel, they will have the same elongation. Okay. Now we can write this as elongation is same. Elongation or compression is same. In this case, we can write K effective value can be written as K1 plus K2. This is a K effective in case of the parallel connection. If it is given like this, block of mass M, and we can see one more thing also there, K1 and K2. Now you can see if I displace the block M right side, if block M is displaced by X distance towards right side, x distance towards right side. Now we can see that K2 spring will be compressed by x, and K1 spring will be elongated by x. So same x in both the springs. If there is a same x, we can write it as K effective value can be written as K1 plus K2. We can observe in this situation, it is not the series connection. Underline this point, they are not in series. Okay. Now, this is about the spring forces and all. In this video, I have given only what are the forces are available. Whatever forces are there, like a weight, tension, normal force. Similarly, I have given like a friction introduction only. More detail we will discuss later. And spring forces. Mainly, I have given 4 forces. I have given how to use these 4 forces into the connected bodies as well as equilibrium conditions are there, that I will explain in the next lecture. Next video I will explain that. Thank you very much.